Okay, hi guys. So now we have another problem which we are going to go through it together. So this is also a problem on absolute functions. So in this problem, we are given an equation in which we are asked to show that this equation does not have a solution at all. You see that? This equation, there are many different ways on how to tackle it. So one of it will be just to try and solve it and show that there is no way of getting a solution, which can be a bit hard to do. And the other one is to use the techniques that we have learned previously on how to sketch a function that has a chain of three absolute functions, and also plotting the horizontal line y is equals to 1 and show that those two, they don't intersect. But what I want to do is to solve this problem using one of the most innovative ways for these kind of problems. You see that? So to solve this problem, what we're going to do, we're going to make use of the triangle inequality um, and see what information can we achieve if we play around with the triangle inequality, especially for the absolute functions that are given. So what we're going to do now is we're going to recall the triangle inequality. So the triangle inequality, it says that the absolute value of a plus or minus b plus or minus c is less than or equal to a plus b plus c for all a, b, c elements of real numbers. So this is what we know, that the triangle inequality give us this kind of information. So here I generalize it because it doesn't matter even if there is an interchange of signs. So even here, if you add plus or minus a, it doesn't matter. So one thing about it is that regardless of what signs you select here, this side is always like that. So this is what we're going to exploit now and see what information we're going to use. So what I'm going to do now, I'm going to consider the following. You see that? So let's consider this expression. So let's consider the absolute value of x plus 5 minus the absolute value of 2x minus 1 minus the absolute value of 9 minus x, which is just me taking these and taking the appropriate sign randomly from there. You will see why I had to give these two negative signs. You see that? So if you look at this thing, what we have inside will simplify to x plus 5 minus 2x plus 1 minus 9 plus x, which simplifies to give us the absolute value of what? So x plus x is 2x minus x, so all these things, they cancel, so we remain with only 5 plus 1 minus 9, which simplifies to give us 3. Sorry, so it gives us 3 there, like that, you see. But this thing that we have here, from the triangle inequality, we have that. So if we were to take the triangle inequality, we know that this expression x plus 5 minus 2x minus 1 minus 9 minus x is less than the absolute value of x plus 5 plus the absolute value of 2x minus 1 plus the absolute value of 9 minus x. But already we have proved that this thing is equal to 3. So this implies from this, it follows that x plus 5 plus 2x minus 1 plus 9 minus x must be greater or equal to 3. So therefore, this function on the left hand side, you see that. So if f of x is equal to the function x plus 5 plus 2x minus 1 plus 9 minus x, then the minimum value of f of x is 3. So this is what we achieve now. So we see that the minimum value of this function is 3. So which means if you are to make a rough sketch of this function, we do not know exactly how it's structured, but we know that definitely the minimum point where this function is going to reach, it's going to be sitting at a value of y value of 3, definitely. So if this is our this is not an appropriate thing because it's actually curving in the negative side. So let's draw something which is much more appropriate. So what we know definitely is that whatever the function is here that we're going to have, this function is going to reach its minimum point at 3. So which means if you are to sketch the line y is equal to 1, there is no way this line can intersect that, you see. So just from this visual image, one can see that therefore it's impossible for f of x to be equal to 1, and therefore that equation has no solutions. You see that. So this is how you're supposed, but one thing to note, this is not in any way necessary. So this is not in any way necessary. It's just included to aid a visual image so that you can understand why we are saying this equation has no solutions at all. Because remember, whenever you're solving an equation, what you are simply trying to find is the points of intersection between two functions. So in this case, f of x is a function on the left and the other function is y is equals to 1. So we are trying to show that these two functions do not intersect each other, and therefore we cannot have solutions. So since we have already shown here that this thing has only a minimum value of 3, it's impossible for this thing to be equal 1, because that will then mean that f of x has another minimum which is 1, but this is not the case, and therefore we have a contradiction. So this is how to solve this problem. So thank you for watching. Meet you next time for